Hi there. Okay, today we're going to do some solving equations, but prior to that, there's a few other little things that we need to make sure everybody is aware of before we move forward into this course. And so one of those is the distance formula. So just as a refresher on your distance formula, remember that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Does that ring a bell, hopefully? Okay, so the distance formula will come up different times throughout the year. So that's one of those formulas you need to know. The other one is the midpoint formula, and that's if you are given 2 points, could you find the midpoint between them? All right, so you're looking for the middle of these two ordered pairs. So you're given an x and a y with another x and y. I always think of the midpoint as I'm just finding the average of the x's. So you'd add them and divide by 2. And then you find the average of the y's. So you add them, divide by 2. And that's an ordered pair that you're getting then for your answer. All right, so those two formulas we need to know. Let's go ahead and just run some numbers through each one of them. So here I have a negative 3, 6 and a 2, 9. If I wanted to find the distance, I'd have, actually, I was going to say, it doesn't really matter which point you start with when I call this x2 and x1, as long as you are consistent between your x's and your y's. So if I was going to do my x's, let's go ahead and say I'm going to do negative 3 minus 2. Now, if I choose to do that, then I have to stick with the first point as I do my y's. So then I'd have a 6 minus 9 if I did that route. Okay, so negative 3 minus 2 is a negative 5. Squared is a positive 25. Plus 6 minus 9 is negative 3. Squared is a positive 9. Those will always end up positive as you square it. That's why it doesn't matter which order you do that. So your distance is the square root of 34. Okay, let's try using those points and finding the midpoint between them. So the midpoint, I would just add my x's, negative 3 plus 2, divide by 2. Add my y's, 6 plus 9, divide by 2. All right, so my midpoint would end up being at negative 1/2 and 15 halves, or 7.5, or however you want to write that. Okay, so be familiar with those. The other thing that I want to talk about is domain, and this is one of the things that comes up a lot at the beginning of this course in the first semester. We talk a lot about the domain. And the domain is basically, if you'll recall, just what your possible x values are. Now, the range is what your possible y values are, and we talk about that as well, probably not quite as much though. Because anytime we're doing some solving, we might solve for x, but we have to make sure that it fits in the domain. Okay, so there's really many times that your domain is all real numbers. X can be whatever you want it to be. There's two main situations that we look out for, and that's fractions and radicals. And so I'm going to take some notes up here where I have a little bit more room. On fractions, you have to make sure that your denominator does not equal 0, because remember, you can't divide by 0. That would be undefined. So anytime you have a fraction, you look at that and try to make sure that you don't let your denominator equal 0. So if we look at these first two examples that have fractions, basically what I'm saying is that the denominator, x plus 5, cannot equal 0. And so if I solve that for x, I'd subtract the 5 to the other side, and so what I'm saying is x cannot be negative 5. That would be a problem because that would create the denominator as a 0. Okay, the second fraction, let's look at it. I'm going to take my denominator and make sure that it cannot equal 0. All right, if I subtract the 4 to the other side and then divide by negative 1, on this one, x cannot be 4, and that would be my domain. All right, so let's try the other type of situation that happens. The other thing we worry about are radicals. Specifically, square roots is what we'll probably be dealing the most with, but we have to make sure that the radicand, which is the value that's underneath the radical, whatever that is, that radicand has to be positive, because if you take the square root of a negative, it ends up imaginary. So this radicand has to be greater than or equal to 0 to keep it positive. So whatever that radicand is, so in this first example down here, I have an x minus 2. So x minus 2 has to be positive or greater than or equal to 0, which then means that x has to be greater than or equal to 2. And so any value, as long as it's bigger than or equal to 2, would work in this. If I picked something smaller than 2, like let's say 1, you can see if I put a 1 in there, I'd end up with 1 minus 2 or negative 1, and that'd be imaginary. Okay, let's try this next one. The radicand on this one is x plus 9, and I want to make sure that it stays positive. Subtract the 9, so x has to be greater than or equal to negative 9. Okay, so we have this last one, this square root of 3 minus x. Notice the x got switched around there. Sometimes that'll mess with your signs a little bit, so let's look at this one. So I'm going to start off the same way. I'm going to take this radicand right here and make sure that it stays greater than or equal to 0. Okay, so now to solve this for x, you can do different things. Some people would subtract the 3 to the other side. Some of you might add the x to the other side. I don't really like my x to be negative, so I'm going to go ahead and add my x to the other side. If you were to have subtracted the 3, you'd have to divide by a negative 1 to get that negative off your x. Oh, and remember, when you divide by a negative, you have to switch your inequality. Okay, so I chose to go this route instead, but the thing I have to watch out for then is to notice that I now have my x on the right side, so my x is actually smaller than what the 3 is, because it's pointing at the smaller than 3 is bigger than x, or x is smaller than 3. So I want all of the x's, I'm going to come back and write that a little bit nicer then, I want all of the x's that are smaller than or equal to 3. So small numbers are good to plug in here, because I'm going to take 3 minus that. I wouldn't want to put in a big number, something bigger than 3, then I'd end up with a negative. All right, so in this chapter, we're just kind of practicing finding that domain, and the two main things you're going to look at are fractions and radicals, and you have to kind of keep straight which one's which. Fractions, you don't want a 0 in the denominator. Radicals, you want to make sure it stays positive. Okay, so now let's move on to the solving equations part. I'm going to kind of assume that you know how to solve some basic linear equations, and in this lesson we're going to kind of talk about just some of the other oddball types of equations that you've come across in the past and refresh your memory on how to solve those. So one of those is when we have like a quantity squared and you want to solve for x. All right, there's different ways to do this. I could actually FOIL this out if I wanted, and then go factor and solve like we did yesterday. But if I actually have a quantity squared like this, there's kind of a shortcut to that, and that would be just to get rid of the squared. Let's square root both sides. That's how you'd undo squaring. So my squaring and square root cancel out, and I just end up with an x minus 1. The major thing that you have to remember, though, when you take the square root of both sides, is that you have to put in a plus or minus on that. So it doesn't equal 3, it equals a positive or possibly a negative 3. That's how I end up with my two solutions there. Okay, so then add the 1 to the other side. And so you look at your two scenarios. If I had a positive 3 and added 1, it would equal 4. If I had a negative 3 and added 1, I'd end up with a negative 2. So I have two solutions for that one. Okay, let's try number 4. Now, before you can do that square root of both sides, you have to get that quantity by itself. So in this case, the first thing I would want to do is divide by that 5. Okay, so now what I'm going to do is square root both sides, and don't forget to put your plus or minus on there. All right, so then I have an n plus 1 is equal to, now this one did not come out near as nicely as the last one. When we square rooted 9, comes out as 3, works beautifully. This one does not. So I end up with a plus or minus. I could break down that radical. Remember that you could break that down into a root 4 and a root 2. which would reduce to a 2 root 2. So I'm going to have a plus or minus 2 root 2. Take the 1 to the other side. So n is equal to, and probably the way I'd write that is a negative 1 plus or minus 2 root 2. And that's actually two different solutions. I could go find decimal values for that if I wanted, but I'm not going to. I'm going to leave it exact. And what this kind of means is that if you had chosen that other method where you'd square this, go FOIL this out, and then distribute the 5, and then get the 40 over here, and then try to factor it like we were doing yesterday. If you did that, if you get this kind of answer, that means you'd be sitting there trying to factor all day long. It wouldn't factor. And so this is a different option to go with. Okay, so let's look at the other type. Instead of having something squared and we square root, let's go the other way. What if the radical is already in the problem? Well, to undo and this one happens to be a 4th root, to undo taking the 4th root of something, then we're going to take it to the 4th power. So roots and powers undo each other, and you just have to pick the one that's going to undo what you need to undo. Now, just like before, though, you want to get that radical by itself first. So I'm going to subtract that 9 because that's not underneath the radical. And so then I'll have a 2. All right, so now to get rid of this 4th root, I'm going to take everything to the 4th power, but I got to do it over on this side as well. All right, so then the 4th root and the 4th power undo each other, and 2 to the 4th power is 16. Subtract the 2, divide by the 7, and there's our solution. Now, here's one of those places, though, where we're kind of paying attention to the domain, because look, you have a radical in here. And since it's an even root, I sure don't want anything under here to be negative. And so that's something to be paying attention to your domain. Like, would this 2 make that negative? And you'd be fine on this one. It's going to stay positive. But that's one of those places where we use that domain. All right, the last type that I wanted to refresh your memory on is those absolute value equations. Okay, so what's going on here is you're taking the absolute value of something and saying that it equals 15. All right, so algebraically what that kind of means is this quantity, this 3x minus 6, was either going to equal a positive 15, and those absolute values didn't really end up doing anything at all, or that quantity 3x minus 6 possibly equaled negative 15, but then we took the absolute value, and that's why we said it equaled positive 15. So on absolute value equations, you're always going to set up two scenarios, and then you solve both of those scenarios. So on the left here, I'm going to add 6 to the other side, and then divide by 3. On the next one, I'm going to add 6 to the other side, and then divide by 3. So you should end up with two possible solutions. Either one of those numbers could be plugged in for x right here and made that work out. Let me show you. So if we plugged in 7, so that would be 21 minus 6. That's 15. The absolute value of that doesn't change it. But if I plugged in negative 3, that would get me a negative 9. Minus 6 is negative 15, but then we took the absolute value and said it equaled 15. Okay, so both of those values work. Let's try again. As always, you want to get those grouping symbols by themselves before you start doing whatever the special situation is. So in this case, the first thing I'm going to want to do is subtract the 15 to the other side. So if I did that, I'd end up with a 6 over there. And then I'm going to get rid of that 3, so I'm going to divide both sides by 3. And so then it would equal 2. And now the absolute value is by itself, and I'm going to set it up just like we did this one. I'll make the y minus 8 either equal to a 2, and the absolute value didn't do anything, or I'm going to take the y minus 8 and make it equal negative 2, but those absolute value are what made me set that equation equal to a positive. Add the 8, so y is 10, or y is 6. Those are my two solutions. Okay, so that's just a handful of some of those special types of equations that you've solved in the past that I kind of wanted to review before we get started in this course. All right, good luck.